Hey folks, this is a quick little Monday video. I think I'm going to start doing this on Mondays, just kind of putting together these short clips to kind of go over a few things that are important but don't require a super long video or a in-depth super explanation, whatever. These are just kind of quick tips. So this last week I picked up a new bow. I bought a Prime CT5, and it's one I've been looking at for quite a while. Saved some money for it. It's the first bow I've bought in the last 3 years and the second in the last 13. So I don't go through bows every year, but this year seemed like the right year, and with Prime coming out with that particular bow, it really spoke to me after shooting a number of them side by side and making the decision. And I will say also, I put some feelers out to some of the, I guess, pros out there, some of the hunting celebrities that get to try everything and whatever else. Corey Jacobson from Elk 101, bless that guy's heart. That guy gave me a very in-depth, insightful, thoughtful opinion of his experience with Prime bows. And his words didn't make the decision for me, but they certainly helped guide where I was looking. So just for Corey specifically, thank you very much. It's very much appreciated, and I really dig the fact that like a regular dude like me can get that kind of advice from folks and be able to pass that on, because ultimately it helped me make a better decision. So anyway, getting to the whole thing. So I picked up the bow, and I was getting it set up at my local shop here in Phoenix, Ross Outdoors, and I was shooting my arrows, which totally makes sense, right? So we were getting everything set up, got the peep height set, knock height, got everything lined up correctly and whatever else. And then while I was test shooting the bow, this was probably arrow number 8 or 10. I heard a loud noise on the shot as I fired the arrow, and my first reaction was I just Robin Hooded or smacked the shit out of one of the arrows already in the target. That was not the case. I had an arrow slightly blow up on me. Well, it was the nock itself blew up on me, which resulted in a partial dry fire of the bow. Not something you want to do with a brand new one that you've got 10 rounds through, right? So myself and the shop tech, we kind of looked into this a little bit deeper, and what we discovered is I've been using pin nocks on my arrows for about the last year, and I did that because when I shoot in the backyard here, I get about 30 yards, and occasionally one arrow strikes another. It's not a Robin Hood, but it's enough to break the nock, and oftentimes with a press fit nock into the back of the shaft, you're going to crack that shaft. You'll put I've seen anywhere from maybe a 1/4 inch to maybe a 1/2 or 3/4 inch long crack in the ass end of the shaft, and it's just from the impact, and that energy has nowhere else to go. So my thought process was, instead of paying the $15 or whatever it is to replace that shaft, refletch it, get it spun, all those different things, why not just have a way to strengthen the back end of the shaft, which for the shafts I was using, they don't make like a knock collar for it. It's a micro diameter shaft. I couldn't find one anyway. So I resorted to pin nocks with the thought that I could just replace the plastic knock if I happened to blow it off, which absolutely and totally worked. However, here's the problem. When the pin itself does not fully bottom out or seat into the hole drilled in the bottom of the nock, that leaves some dead space in there. When you fire a bow, all that energy is transferred first to that nock and then through the rest of the arrow to propel it forward. That little gap there causes a problem. It tries to force the nock down onto the pin, and you wind up with a nock that has a hairline crack in it. That's what we have determined. This is completely unscientific, but that's what we have determined happened with my bow just the other day or last week. So in trying to research or determine what was the problem here? One of the guys at the shop, they've got a caliper, a micrometer that has like a depth gauge on one end. It's got a little finger that sticks out the back end that will measure the depth of a hole. So what we discovered is, get the glare out of here. What we discovered is the pin right here has a post that measures, what does it say, 7.04 millimeters of height. So from the flat spot where the knock rests at the base up to the top of the post, 7.04 millimeters. The hole drilled into the center of the knock, which is what presses over the top of the pin, is 8.63 millimeters. That leaves a difference of 1.59 millimeters of dead airspace between the top of the knock and the bottom of the hole, basically inside the plastic knock. Now the pins that I'm using have a tapered shoulder here, right at the base, just before they meet the shaft itself. So that tapered portion seats against the shaft, and then it tapers up to it tapers up to the corner of each corner of the knock as it sits on the pin. So the assumption is, anyways, that the force of this string that is pushing down here into the knot groove, upon firing, that string is moving forward and it's compressing this plastic, trying to push the rest of the knock down to the top of the post. And these corners here where the knock ends that's trying to ride up on this taper, and that was causing a crack in the knock. Now right here this is the pin itself. I hope you can see that. It's pretty dinky. So this is, from here up is what fits in, or from here down is what fits into the shaft, and then from the tip of my finger here up to this finger is what is sticking up out of the arrow shaft. And then the knock itself, again very small, that sits right on top of that pin, and you press fit that all the way down. Now once it's all the way seated, see if I can get this done. Well, it's a pretty tight fit. Once it's all the way seated, the flat bottom end of the knock here sits right on top of this shoulder at the bottom of that pin, and that's right where that taper begins. So where I was finding the crack was, if that's the way the knock looks flat where you can see the groove, it was 90 degrees to one side, and it was right up the edge of the knock. Now when I fired the bow tech himself, he was watching me shoot it, and he watched the knock come apart and fly off downrange while the arrow continued onto the target. So it wasn't a complete dry fire, but it was enough that the serving on the cable, see if I can put this up here for some contrast. Holy cow. So the serving on the cable here, or the yoke, you can see those two frayed parts. One's like right there, and then the one's more towards the middle. The serving itself, this is the yoke that the yoke that goes over the cam, and then it sits in, I think that's what it is. Yeah. And then it sits on that little plastic yoke dowel thing, whatever they call it. I don't know what they call it. But it blew the serving out of that thing. It didn't compromise the inside fibers of the string, but you continue firing something like this, and the serving's just going to continue to unravel and unravel until you get the actual string core riding directly on the cam, and possibly causing some more problems with that. So fortunately, Ross Outdoors had a spare string set for a CT5, and they just threw on a new yoke for me, and that pretty much solved the problem. But this whole pin knock thing is important enough to me, because that's a major safety problem. Like, had that really dry fired, I could have blown apart the entire bow. and not only wasted all that money and screwed all that up, but injured myself in the process. So since that time, I've pulled all of the pins out of my arrows and replaced them with Easton Deep 6 Nocks, which are highly reliable, super well designed, very, very short distance between the throat and the bottom of the nock, so the energy transfer is really fast, or very efficient. But it's something that's important enough that I think you should be aware of, because this is an easy fix, right? Like, I smack the nock on this, I break the nock, I just pull it off and replace it, put another nock on the pin, and it all makes perfect sense and it's logical. And I suppose if there's a better pin nock system out there that is designed to not have this problem, or addresses it, or maybe just a little bit more precisely whatever drilled out, then that's that eliminates the problem. On the other hand, maybe pin nocks aren't really designed for hunting bows that are set at 70 plus pounds, because when I checked the rest, like the entire dozen of my arrows that I had out there, 8 out of the 12 had micro fractures in the plastic nock, and all of that had been done while shooting my Elite E35 at 76 pounds, and this is a 485 grain arrow. So now I moved to a new system, the Prime CT5, which, by the way, gave me 15 feet per second of speed, using the exact same arrow and set at 75 pounds. That's pretty impressive. So obviously the Prime is a more efficient bow in terms of delivering energy to that arrow. So that's just putting more energy into these parts. And if one of them is compromised, like mine was, something's got to fail. So just keep these things in mind. Check your stuff over. Make sure that you're doing things for the right reasons, and being extra cautious and safe, because the last thing you need is a carbon shaft through your forearm, or a bow that comes apart in your face. Okay. Thanks for watching. I will have more of these short ones, kind of short. I'm already at like 12 and a half minutes. More of these short ones in the future that just go over specific things like this, and hopefully help you out and help you avoid maybe some of the failures or the bad decisions I've made. Okay, thank you.